In this lesson, we shall focus on complex analysis. And I want us to do exercise 8 at the moment. Right. And so find all complex numbers Z of the following equations. Right. So if you have Z cubed, which equals minus 1 plus I, then what we then do is to plot this complex number, we plot minus 1 and then we plot I. And then you have this. Imaginary, then real Z. So now R becomes the modulus of the 1 plus I, which is the magnitude, which becomes the square root of minus 1 squared plus 1 squared, which is the square root of 2. The tangent of theta, which is y over x. Y is 1, x is minus 1. Okay, so it's minus 1 this. So now there's something called a reference angle. So we get a reference angle. So reference angle is going to be arctan. Okay, note that if this one, it's minus 1 here, and then arctan this is pi over 4 radians. Okay, so, but now this angle is going to be pi over 4, but we're interested in the angle theta. So the angle theta is going to be pi because this is pi and this is pi over 2, and this one is 0 to pi radians. And it's again 3 pi over 2, which is pi minus. So we're going to do pi minus. Which is 3 pi over 4. Plus I sine theta. The angle of theta is this one, 3 pi over 4 radians. And this is 3 pi over 4 radians. Okay, so if then this is the case, let's write properly. Okay, I want to write this in some detail. Which means you have Z cubed. Which is R cosine theta plus I sine theta. Plus I, the sine of pi over 4. 3 pi over 4. We measured the angle, we found 3 pi over 4. Right, so we have 3 pi over 4. So which means we have Z cubed. Cosine 3 pi over 4. All right, so what we have here is exactly the following. Right. Right. Okay. Okay, continue. Okay, so you have exactly this. Right. Okay. So now what you then do, you can still keep this one as the third. Right. We continue, please. Okay, if this is right. Okay, we continue, please. Right. Oh yeah, okay, I was saying it's square root of 2 here. Cosine 3 pi over 4, then what you do, you add 2k pi, and then the sine, you have 3 pi over 4, you also add 2k pi. Right. We continue. So yeah, we're just learning how to solve these equations. Right, so obviously. And then now, if we get this, then we're finding what we call the cube roots. Cube roots, so that z becomes the square root of 2, then you raise it to 1/3. Two k pi of 3. So now we have 2 to the 1 out of 6. Okay, so this is the cube root. So this is what we have. Eight k pi divided by, multiplying through by 4, getting a 12 here. Okay, so you have something there. The yards. Okay, I did not find all the answers, of course. I didn't find all the answers. But yeah, but if you simplify these, right, and continue. Right. So we continue. Right. Okay, y'all. Okay, this is the answer, but it simplifies to this exactly, yeah? It simplifies to this exactly because what you have here is pi over 4 plus 2k pi out of 3 plus I, the sine of pi over 4 plus 2k pi out of 3. K012. Yeah, so this is the case, but because the cube root, 1, 2, 3 roots. So we take those three values there. We take exactly those three values there. Take exactly those three values. Any question? Right. So if you have questions, please let us know. There's something you do not understand, please let us know. So that we can answer the questions you do not understand. Okay. Right. Right. Okay, yeah, let's try the next one. We do the same. So we try now. This was A. Let's try B. So B, it's a z to the 4, it's minus 1. Okay, yeah, what is the K for? Right, the K is just for substitution purposes and to get the actual roots. Because now when K is 0, let's just show some examples. If K is 0, then Z is 2 to the power 1 out of 6. Then you put 0 here, which will be cosine of pi over 4, 2 times 0 pi out of 3. Pi over 4, 2 times 0 pi out of 3.
Sorry.
Yes, please.
Hello.
Yes, please.
Yes.
Okay, we're not
I want
hearing
to
me.
ask, how do you know when to? Sorry?
Okay, that's fine. Go ahead. I thought you were not hearing me.
No, I can.
Okay, thank you. Yes.
So, how do you determine whether to write? You see, how number C is answered this. You said 0, K is equal to 0, 1, 2, 3. Then number A is like K is equal to 0, 1, 2. So, how do we know whether to write 0, 1, 2 or 0, 1, 2, 3?
Oh,
K is equal
yes.
to
All
0,
right,
1,
all
2,
right.
3.
Yeah.
Then
Because
if you get
because
me.
here, the power is 3 here. So if you solve an equation that is x cubed equals 4, you're looking for the cube roots. So the cube roots must be 3 roots. 1, 2, 3 roots. So let us explore the effect of the K a little bit. Okay, but now you'd remember that. Okay, good. Yeah, because it's the cube root, so there must be 3 roots. That's fine. Then we have 2 to the power, it's this one. 2 to the power 1 out of 6. Cosine of pi over 4 plus 2k pi plus I, the sine of pi over 4 plus 2k pi. K equals 0, 1, 2. Okay, then you start and say for k equals 0. I mean, you get all the roots. So for k equals 0, you have 2 to the power, just that they did not finish it. So now for k equals 0, then you have the cosine of pi over 4 plus 2, 0, pi, and then pi over 4, 2, 0, pi. Okay, we put 0 here, which It's 2 times 0 is 0, and then it's cosine pi over 4 plus I, the sine of pi over 4. Right. Okay. Okay, continue. Right. Okay. So if you multiply everything to the power 1 of 6, 1 over square root of 2, and also 1 over square root of 2. So this is the answer. So you can write your answer like this, but you can also write it as 2 to the power 1 over 6 divided by the square root of 2, 1 plus I. So what would 2 to the power 1 over 6 minus 1/2 be? Because this is like the 2 to the power 1/2. So what would this one be? So it's going to be minus 2 out of 6. Yeah, minus 2 out of 6. Minus 1 out of 3. Minus 1 out of 3. So that Z is 2 to the power minus 1 out of 3, 1 plus I. One plus I yeah, so we have this, and then we're gonna actually do this is the first root. So for k equals 0, that is the first root. Let us do the the next one. This is for k equals 0, then we're gonna do for k equals 1 because it's 0, 1, 2. 0, 1, 2. So let's do for 1, right, which is 2 to the power 1/6, which is cosine of this. You see, if you put 1 here in the place of k, you put 1, we're going to have pi over 4 plus 2 pi over 3. LCD 12. 12 divided by 4 is 3, giving us 3 pi, and then divided by 3 is 4, which is 8 pi, giving us 11 pi out of 12. Right, so we continue. Right. 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 Okay, we continue. Okay, yeah, we are continuing, please. Okay, I was saying for k equals 1. Then if you put 1 in the place of the k, if you put 1 there, then you have pi over 4 plus 2 pi of 3. Right. Yeah, okay, so it's going to be the pi over 4 plus 2 pi of 3. Yeah. Is it 2 pi of 3? Yes, it is 2 pi of 3. Let me check. Yeah, pi over 4 and then 2 pi of 3. 2 pi of 3. But now that gives us 11 pi of 12. Okay, let's check. 11. Okay, yeah, and then now when you get to this point, then you can use a calculator because the 12 is a bit tricky. Right. So, okay, yeah, let's check this one. Okay, I want us to do this one on the calculator. Right, so it's going to be cosine 11. Right, we continue. Right, 11. Yeah, 11 pi. Okay, yeah, so, okay, you have 11, then pi out of 12. And therefore, you close like this. It's exactly that. So, right, so now, okay, the calculator is in what? It's in degrees. So I need to change it to radians. Just 1 minute. So degrees, radians, let me put 4 radians. So, which means the cosine of 11 out of 11 part of 12 is that one, which is exactly minus square root of 6 plus that. What is it? Okay, we got minus square root of 6 plus the square root of 2 over 4. Let's do the sign. So we're going to do right. Then you do sine, which is that. Square root of 6 plus square root of 2 over 4. Okay, yeah, this is for k equals 0. What we're saying here is that for k equals 0, one of the roots is k equal to, yeah, one of the roots is k, is z equals 1 over the cube root of 2, in brackets 1 plus I. Okay, good. All right, yeah, let's explain B now. Okay, we're moving to B now. B is the next big thing. Okay, now to explain B, B is the same, but they wrote the answer in full. So now, but it is z to the power 4 equals minus 1. You sketch it. You have minus 1. You measure the angle there with theta equals pi radians, which is this real part of that. So, okay. Right. So we continue. Right. Right. Okay. Right. Okay, yeah. So the modulus of this is 1. Well, because it is minus 1 plus 0i, which is the square root. Which is 1. Then the angle theta right. Okay, this is the thing. Okay, let us do this. What is the angle theta? The tangent of theta is y out of x. Y is 0 to x is minus 1, giving 0. Which means that the theta is arctan 0, which is pi. The z to the power 4 is equal to minus 1. Every complex number in rectangular form, right? Every complex number in rectangular form can be written in polar form, in r theta form, like this. The r is 1, the theta is pi, and therefore now this is 1 cosine of pi plus 2k pi. Right. Which is pi plus 2k pi. Right. So now if we have the z, because this one here is going to tell us, this 4 tells us about what? The fourth roots. Fourth roots. Okay, there are 4 of them. And so obviously this is 1 in front here. So which means you're going to have 1 raised to 1/4. The cosine of pi plus 2k pi, you divide by 4, plus I, the sine of pi plus 2k pi, you divide by 4 also. Right. Z plus 2k pi, you divide by 4, pi plus 2k pi, you divide by 4. But this one is going to be k equals 0, 1, 2, 3, because it's 1, 2, 3, 4. 4 roots. But because the 4th root, then we always start from 0, but we stop at 3 because it's the 4th root. So there are 1, 2, 3, 4 roots. Let us find some of the roots. Okay, they wrote the answer here in a simplified manner. Okay, so for k equals 0, we put 0 there, which means that is cosine of pi over 4 plus 2, 0 pi, pi plus 2, 0 pi, which is pi over 4 plus I, the sine of pi over 4. 1 over square root of 2i over the square root of 2, which is one of the roots, plus, and then you have this. But because it's a power 4, then you need 4 roots. You need 4 roots. Okay. So now we got 1 root. Let's use a different color. Let's use green. For k equals 1, it's going to be cosine of pi plus. Right. Pi plus 2 by 1 pi. Two by 1 pi. Right. So we continue. We continue. Right. So what do we have? So it's going to be pi plus 2 pi is going to be 3 pi over 4. The sine, either sine of 3 pi over 4. Cos is negative in the third quadrant, because if you do pi over 4, 2 pi over 4, 3 pi over 4. Right, if this is 3 pi over 4 sitting here, then you're going to have what? Negativity. The cost rule is applicable. Giving and making the cosine in the 3 pi over 4 quadrant, the second quadrant, cosine is negative, but it's minus 1 over the square root of 2. But the sign is positive there, being I over the square root of 2. So we got another root. So we also got the minus plus root. So here, this described 4 solutions. 4 solutions. The plus solution, minus solution, plus minus solution, minus solution. So this description in B describes 4 solutions. For K equals, yeah, but you see, there are other ways to do these. But here we are using de Moivre. But you can do this using high school methods. So you can quickly get this answer. But we don't want those high school methods here. We want de Moivre. So for K equals 2, yeah, okay, good. And then now, okay, let's move on from exercise 8. You understand it? And then now, okay, let me check what else must be done. Okay, we haven't done exercise 1 to 4. Which ones are those? Is this exercise 4? Okay, I might have not included some of the things. Okay, yeah. Let me check what you're talking about. Okay, let me go to the chart, please. I'm going to the document now. I'm going to the document to check. I'm going to the document to check. Okay. All right, let me check. Yeah, I'm going to your things now. I'm on your WhatsApp. I need to check the documents. I might have missed some things because I was just trying to cut out some of the things, trying to balance up. Time was against us. We're running. So I'm going to the complex numbers document. I'm going to the complex numbers document. Right. Okay. Yeah, exercise 1 is this one. You see, I thought it was too easy last time. To page. Okay, I'm looking at the document now. Okay, I'm looking at the document now. So I'm going to include some of the things. Let me include some of the exercises. So I'm going to include these exercises. Right, so. Okay, I'm including some of the exercises here. Just 1 minute. So that you can do some of the exercises. Okay, I'm including some of the exercises, please. Okay. Right, so let us include, okay, let's look first at the examples. I'm going to include just some of the examples. Okay, so 1, 2, 3. Right. Okay, I'm including the exercises, yeah? Okay, good. Let me see what you're saying. Okay, good. Yeah, that's fine because I think I found it. I found it. Okay. I found this exercise. Right. Okay, I found it. Exercise 1 is this one. Right. So we continue. Continue. Okay, we're going to also discuss some of the notion of the conjugate. And then exercise 2. But I found the stuff. Right. I'm including the conjugate. Right, I'm including the conjugate. Yeah, I'm including the conjugate. Right. Okay. I'm including this one here, the tart. Then we also have this one. Right. So we continue. Right. Okay. Right. So we continue. Right. Okay, y'all. Just right. We continue. Then we're gonna do this one. That's exercise 3. Then let's do exercise 4. Right. We continue. So we do this one here. Include exercise 4. Okay. Okay, good. I agree with you. We can't do all the questions because of limited time. Yeah. We can't do all the questions because of limited time. I agree with you there. Right. Okay, yeah, let us get cracking. Let's get cracking. Right, so we're gonna do. Okay, let's start quickly and review these examples and then do those exercises in pages 1 to 5 or something. All right, so let us spend time on this. And okay, we are going on. Now, looking for example at part A, where we have in A 1 plus I2 plus 3 plus I4 is 1 plus 3, which gives 4. I2 plus I4 gives us I6. So how do we do this? There is an explanation to this. Right, there is an explanation. So to have the 1 plus I2, 1 plus 3, 1 plus 3 is 4, I6. Right, so yeah, let's check this out. So now if you're going to deal with B, for example, is I3 plus I4. You multiply. I by 3 gives us I3. I by I becomes minus 4. And the answer is minus 4 plus I3. We start with the real part and then we end up with the imaginary part. Okay. Now, in this example, we're going to look at this part. So 1 plus I2 multiplied by 3 plus I4. 1 by 3 is 3. And then we have 1 times I4, which is I4. I2 by 3, which is I6. I2 by these, which is minus 8. And then this is going to be 3 minus 8 plus I4 plus I6, which is minus 5 and then I10. Is it? Okay, let's check this out. Let us check these out. Right. Yes, it appears to be exactly the case. Right, so if this is true, then you can take out, this is written in terms of the real part, the imaginary part. You can have minus 5, 1 minus I2. And that is the answer. And that becomes the answer. Okay, which is exactly that. Let's look at the next question. Okay, I wanted us to just do, say, exercise 1 as well. So now exercise 1, for example, would be write in the form x plus iy, these things. So if you look at part A, you have 4 minus I3 in brackets. 2I minus 8. We have 4 minus 8 minus I3, 2I. 4 minus 8, it's minus 4. Minus I3 plus 2I is minus I, which is exactly the answer they got. Right, looking at part B, and this answer has been written exactly in the form x plus iy. That is the form they wanted. Right, in the form x plus iy. So we continue. Yes? Okay, good. Let us do C. Okay, there are two C. Right, so if you do C, it's going to be I minus 2, 1 plus I minus 3I minus 1. I minus 2. Right. I minus 2. Multiply 2 times 1 is 2 plus 2I minus 3I plus 3. I minus 2, 2 plus 3 is 5 minus I. I by 5 is, can write it as I5. Right, so can write it as what? Can write it as I5. And then I by 5 is I5. I by minus I is plus 1 minus 10 plus I2. And then 1 minus 10 is minus 9 plus I7, which is this. Okay, now let us trial this one also. C, because you mentioned that part. Okay, but let's try A first. Oh, let's try, it doesn't matter. C first, and then we shall try the rest. Okay, let's try C here first, and then we're going to do A and B for the imaginary and the real parts. So if we have cosine alpha, I sine alpha, cosine alpha, I sine alpha, cosine is cosine squared, alpha. Cosine alpha and minus I is minus I. Cosine alpha, sine alpha. Plus I, sine alpha, cosine alpha. Plus sine squared alpha. Cosine squared alpha plus sine squared alpha, we group the real parts. Pull out I, then you have a minus, but these things that just cancel out anyway. So without cancellation, but we know that cosine squared plus sine squared is 1. So the result becomes a 1 there. Right. Right. So we continue. Okay, let us try A, for example. Right, so if you try A, which is exactly this, would have the imaginary minus I, 1 minus I, the square root of 2. which is the imaginary part of the square root of 2 minus I minus, distribute here, minus I times 1 is minus I. Minus I times minus I becomes minus 1. But the square root of 2 there. And therefore, this is the imaginary of square root of 2 minus square root of 2 is 0, giving minus 2I. The imaginary part of this is only minus 2. That is the reason they got minus 2 there. So the imaginary part of that is only minus 2. That is the reason why they got minus 2 there. Right, so we continue. We continue. We continue. Right, so what do we have here? What do we have here? Okay, let us see what we got. Let us see what we got. Let us deal with the real part. In part B, we need to find the real part of this. So to find the real part, we must separate everything. We must write the interior argument in the form x plus iy. So that is what we have. Let us see what we've got there. Right. Right. So now if you do the real part, 3 plus I so you continue. And then we have 3 minus I. One over 10. Okay, let us multiply these things. Real part. So this is a difference of two squares, this. Because when we see a squared minus b squared, which is equal to a minus b, then a plus b. This we call the difference of two squares. Right, we can call this difference of two squares. 3 times 3. It's 9 plus 1. 1 out of 5 plus 1 out of 10i. 1 out of 5 plus 1 out of 10i. So what is this? 9 plus 1 is 10. Right. Which is 2 plus I. What is the real part? The real part is 2. The real part is 2. The real part is 2. Right. Okay, so yeah, the real part is 2. Let us try some other problems. Okay, yeah, that was exercise 1. But as said, B is very easy because we have, okay, yeah, how is it 2? Okay, because they also got 2 here. Okay, well, I'm checking. But obviously, because if you need to take the real part of x plus iy, the real part is you choose x for the real part. You choose x. For the real part of x plus iy, the real part is only x. But if you need the imaginary part of x plus iy, the imaginary part is only y. You don't consider the I. Well, you don't take the I, so that is what we have here. So, okay, so yeah. Yeah. Yeah, so the real part of 2 does not affect the answer. Yes, it will. Yeah, because the real part of this is the what? The real part is only the 2. The real part is only what? It's only the 2. That is the real part. So the real part is only this. So the question is, what is the real part? The real part of 2 plus I. The real part is only 2. If somebody wanted the imaginary part of 2 plus I, the imaginary part will be 1. So, yeah. This is what then would be the answer to B and then the answer to A also. Let us look at some more exercises. Let's just look at some more exercises. Okay, now we want to just discuss the proofs here or the properties. Okay, here I want to discuss the properties. So the following properties follow immediately from the definition. If x and y is a real number, then this is the case. If x and y is are real numbers, the implication is therefore that z, which equals x plus iy, we can define z bar, which is x minus iy, and this is called the complex. Called the complex conjugate. It is called the complex conjugate. So z is real if and only if its complex conjugate is z. So if z is real, if z is real, it means that z is x only. It does not have any imaginary part. It doesn't have any imaginary part. Right, so if it doesn't have any imaginary part, it would have exactly the following. It have exactly the following, yeah? So if z is real, then it's only x. If z is real, then it's x plus 0i. Then when you take the complex conjugate of that, it would be x minus I0, which is x. So that z bar is only x. Z bar is only x. Yeah, for the real part. So now, in this case, we can see that z is x, and also the complex conjugate is x, and the meaning is then that the meaning is then that Z is X, which is Z bar. Okay, so take a look at that and make sure you understand what is happening there. Take a look at that and make sure you understand what is happening there. So when Z is real, it means that Z is equal to its complex conjugate. And this means that it's real. Okay, let's look at the next question. So in B, if you take the complex conjugate twice, it's the same as that. So if Z is X plus IY, then you take its complex conjugate, which is X minus IY. You take another complex conjugate again, 2 times. It becomes, you change the sign of the negative IY, it becomes plus IY. But the plus IY is what? Is Z. And this means if you take double complex conjugate, it is the same as that. Right. We continue. Okay, let us look at C. How do you prove C? To prove C now, it's Z plus Z bar. Z is X plus IY. The complex conjugate of that, you would have what? Which is, okay, so y'all can do it carefully. Can let Z to be X plus IY. Right, so that's, the left-hand side is Z plus Z bar. Z is X plus IY. The complex conjugate of Z, you can put X plus IY like this in the place of Z. But the complex conjugate is what? Right. Right. We continue. So which means that there's X minus IY. X plus X is 2X. But, right. Right, so that now whenever Z is X plus IY, we know that we can get 2 things out of it. The real part of Z is X, and then the imaginary part of Z is Y. So that 2X is going to be 2 times the real part of Z. So we continue. We continue. We continue. We continue. Okay, yeah. As a consequence, according to this, this is equal to the right-hand side, yeah? So that then as a conclusion, it is true that z plus z bar is 2 times the real part of z. So we continue. We continue. Right, let's check the next thing that you need to understand. What is the next thing that you need to understand? Right, so in other words, if you add z to its complex conjugate, it is 2 times the real part of that. Z plus z bar is 2 times the real part of that. Well, it means that z plus z bar is 2x. Right. Right. So, but yeah, you come to the, let z be x plus iy. Then the left-hand side is z minus z bar. Right, which is x plus iy minus x minus iy, which is x plus iy. Because when you take the complex conjugate, it becomes minus, and then you distribute with the negative, it becomes minus x plus iy. X minus x is 0, which is 2iy. And so what is this? Or you can write I2y. I2. What is y? Whenever z is x plus iy, this means the real part of z is x, and then the imaginary part of z is y. So that means y, which is the imaginary part of z. Imaginary part of z. Imaginary part of z. Imaginary part of z. So we continue. We continue. So we continue. Okay, let's look at the next one. Let's look at the next one. What is the next one? I'm just playing around with these to show these things. These are the properties, but also the E. If you take the complex conjugate of a sum or difference, this bar sits on the Z1, it also sits on Z2. But if you even have a product, So Z1 plus or minus Z2 complex conjugate like this is the complex conjugate of Z1, complex conjugate of Z2. Z1, Z2 complex conjugate will be Z1 complex conjugate, Z2 complex conjugate. So in other words, if you have a product, the complex conjugate of a product is the same as what? Product of the complex conjugate. But dealing with the sum, we have exactly the following. We have exactly the following. Right. We continue. We continue. Right. We move forward to the next question. We move forward to the next question. Let us deal with yeah. Yes, that's it for E and F. Right, that's it for E and F. But these ones can be proven, this. So you can present a proof in terms of why does this complex conjugate break into two pieces? Because it's one piece, now it's two pieces. How does it happen? There's a mathematical proof. So to present a mathematical proof, you can let Z1 be X1 plus I, Y1. You add them up. Right. Right. So which means you have exactly this. Okay, you can just present a proof in terms of why this is the case, because they can ask you to prove something in the exam. If the exam is written and you need to write some steps in terms of why this is the case, or you can justify with a proof. Right, so now if this is the proof, then this would be x1 plus I, y1. You distribute with a plus minus. So the plus minus is going to be plus minus x2. Right. Right. We continue. Okay, distribute with the plus or minus, and then if you do, y1 plus or minus y2. Plus or minus I, y1 plus or minus y2. Right, so now we can play around like with it like this. But this you can write as exactly x1 plus or minus I, y1 And then you can put plus or minus x2 plus or minus iy2. So we continue. So, which means therefore, what you're going to have here is that this one is going to be the complex conjugate of, it's going to be the complex conjugate of Z1. Okay, check this one out. Okay, I know we've done it in very cumbersome ways. Plus or minus, and this is the complex conjugate of Z2. Like that. In particular, when you're dealing with Z1, Z2 single complex conjugate, we have Z1, which is X1 plus I, Y1. Z2, which is X2 plus I, Y2. So you can write out this. Obviously, in this case, we'll let Z1 be X1 plus I, Y1. X2 plus I, Y2. And so now you multiply everything. X1, X2, X1, Y2. X2, Y1, Y2. Right. So now you have X1, X2. You group the real and imaginary parts. X1, Y2, X2, Y1. Yeah, this one is going to be the last one for discussion because I have another class at 4. And then we're going to start again. You can do 6. But again, the class at 4 is going to start it from 4 and stop at 6. Then we can do 6, X1, X2. You can try 6 if you are free at that time. If you're going to church or something like that, we can start at 8. So yeah. All right, that's fine. So now then we have the complex conjugate giving a minus there. Start from the margin. So now this is going to be exactly what? So we continue. We continue. Okay, we continue. So now at this point, the complex conjugate has made the plus a minus. And then what is this? Well, we argue that this can be factorized to x1 minus I y1, x2 minus I y2. Which is z1, z2. Right, so if you factorize this thing, it can be factorized into this, so that z1 dot z2, the product with the complex conjugate, then it's exactly that. So it means that the complex conjugate of a product is the product of the complex conjugates. One complex conjugate is two complex conjugates. from this property. And therefore, we're done for today. I must thank you for joining us. It was awesome having this discussion. Right. Actually, we're concluding this discussion. I have another discussion at 4 in the next 5 minutes. So yeah, we'll see you then at 6. Thank you so much. As I said, I'm keeping this recording. I'm planning to send a lot of the recordings today. Yeah, I know. Okay, that's fine. Right, yeah, but I have another class now, so it means I can only send after my class. So yeah, but I might be able to send today. Thank you. Goodbye.